So hi guys, in this video we're going to talk about one more interesting problem from blind scientific series, which is product of array itself. Without wasting much time, let's get into the problem statement. So basically what the problem asks you to do is you need to find the product of every other element in array except itself. If you take this position, we just need to neglect this. I need to find the remaining product. If you do that, you're going to get obviously 24. That's what here. And if you take this position, you just need to find all other product except this one. If you do that, you're going to get this side 12, this side 1. If you multiply this, you're going to get 12. That's what here. And if you go to this position and this side product will be 2, this will be 4. If you do multiply, you will get 8. Again, if you take this position, take the multiple of all other element, which is 6. This sounds very simple. Now let's talk about the brute force solution. Brute force solution is pretty simple. You can just put a 2 loop and you can directly multiply and append the list. It's very simple. Let me write the brute force code for you guys. First, just declare a result and start looping from I is going to be 0 up until the end. And again for j, start j from again you have to start j from 0 because you have to compute the previous number, isn't it? For this, you have to see, if you take this, you need to compute this from this sum. So start from 0 itself till the end, and this is a base condition. If I is equal to j, you have to continue, because I is equal to j means it's meeting the same number. So when I and j will be same as at this particular case, if you take this number, I and j will be same. Again, if you are iterating this number, I and j will be same. So we need to skip the product of itself. That's the reason we are skipping this. Remaining thing is pretty simple. I have the temporary variable here. It's going to be 1. Now temporary variable multiply is equal to nums of j. That's it. That's very simple brute force solution. And at last you just need to do result dot append temporary. This is simple brute force solution, isn't it? Its time complexity is going to be obviously of n square, because we are iterating a 2 loop, and then space is going to be of 1. It's a pretty simple solution, and people who are really good at math, they might find some solution, which is solution 2, but it doesn't work in all the case. First, let me tell what is a solution. If you take this array, and let's do the product of all the number. If you do product, it's going to be 24. And people who are really good at math, they might find out this solution. Okay, so what the solution is, you just find the total product and do division operator. Actually, in the given question, you should not use division operator. That's the cache. If you use this one, there is a lot of cache. Why it doesn't work? Okay, first let me show you the solution. What you can do is, you can do 24 divided by 1 and 24 divided by 2, 24 divided by 3, 24 divided by 4. If you do this, you're obviously going to end up this original answer which we computed here. Okay, just do division operator. You're going to get 24, you're going to get 12, and then 8, 6. It's very simple mathematical solution. If just take the product of entire array and just divisible by this element. If you want to compute for this position, divide by this element. You want to compute for this position, divide by this element. It's very simple, but I don't pass all the test cases. The reason, because the given integer will be ranges from 2 power 0 to the 2 power 32, I guess. Till this range only we can able to compute the number. If we go beyond, the system will become different. The number system will become different. So if you see the constraint for the array size, it's going to be ranging from 1 less than or equal to nums less than or equal to 10 power 5. Assume 10 power 5 numbers. If you do product of it, it obviously going to reach this integer range. It obviously going to get beyond 2 power 32 values. Okay, that's the reason it doesn't work. If it's good beyond 2 power 32, even if you divide, it doesn't work. Solution was not going to accept for this. That's the reason you should not use division operator. Now let's move to the very optimal solution, which is using prefix and suffix sum. You can ask me, Mahesh, what is prefix and suffix sum? It's very simple. Let me explain to you guys. Let's take an initial array. Let's have prefix suffix array, prefix, and this is going to be suffix, or some people will tell postfix. The what idea is that we will compute the multiply from right to left and left to right. So what I mean is, in this position it will be 1, and if you come here, what is the product? I mean, so far what is the product of that element? So far, if you come this place, so far product is going to be 2. Again, if you come to this place, what is the so far product? It's going to be 3. Again, if you come to this position, what is the so far product? It's going to be 12, isn't it? This is a prefix sum. If you take postfix, what is the product so far here? What is the product so far here? What is the product so far here? You will compute like this. So with this idea in mind, let's fill out this table. The product so far, this is 1, and product so far here, it's going to be 2, and here it's going to be 6, and here it's going to be 12. Okay. Now let's compute product from the back side. So product here, it's going to be so far 4, and if you come this side, it's going to be 12, and if you come here, it's going to be 24, and here it's going to be 24. Now you have prefix and suffix product. Okay, now what you can do is you can use this to compute our result array. It's going to be result array. How you can compute, you can ask me. So it's very simple. It's very simple. Okay, so what you can do is for this, what you did, you can ask me. I mean, just remember what you did. You just compute prefix sum and suffix sum of it, isn't it? Now we have prefix and suffix sum here itself. I mean, prefix product, suffix product. Okay, we have here itself. What you can do is you can just look at this and you can see what is, if anything is this side. Okay, right now we don't have anything. Just assume there is 1 here. For out of bounds case, just assume we have 1 here. Okay, don't get confused. If you look at this position, there's no thing on the prefix side. Okay, just assume 1 is there, and for suffix side, just look at, if you look at this side, you're having 24 value. What you can do is you can directly multiply 1 and 24, which will give you the result of this position. Okay, we can write 24 here, and if we take this one, okay, if you want to calculate the product for this position, what you can do is look left side to the prefix sum. What is the prefix so far? And if you come this position, if you want to compute for this position, look left side for this and right side of suffix sum. Right side we don't have anything, so assume it as 1. Now if you do 6 into 1, you're going to end up in 6. This is how you just compute the product of array itself using prefix and suffix sum approach. But if you see, the space is going to be, time is going to be O of n, the linear time solution. Okay, you're just going to iterate from left to right and right to left separately. So it's going to be O of n time, and space is going to be O of n again. To store this value, you need additional space. And if you guys want to cut out from here, you can just leave and write the solution. And there is one more optimized solution which doesn't even require this one. Okay, without this we can compute prefix and suffix sum. If you guys want to see the solution, you can continue. If not, you can pass it here and start solving it, and I mean start implement this solution by yourself. Now if I want to talk about the optimal solution, very optimal solution without using this one, so that our space is going to become constant 1, how we can achieve this is going to be, let's see how we can achieve. Again, for the solution also, what we are going to do is we are going to iterate from left to right as well as the right to left. 2 iteration will be done. At first iteration we just insert the value. Okay, and second iteration we just update the value. Stay with me, let's solve it together. At initially the prefix sum is going to be 1, so just put it here. And I mean at initially prefix sum is always going to be 1, just put it down here, and just multiply 1 with this element. Obviously going to end up with 1, and now our pointer will move this side. Now we are at the 2 position. Again, just update the prefix sum. Current prefix sum is going to be 1, and update the prefix sum with 2, multiply with 2, which is the current number. Now our prefix sum is going to be 2, isn't it? Now move to the next position. Now we are at the 3rd position. So far the current prefix is going to be 2. Update it, and now update our prefix. Multiply by 3. Now it's going to be 6. Just move to this position. What is so far prefix sum? So far prefix sum is going to be 6, right? So update so far prefix sum there. You can just update and keep. Now this is going to be 24. Now we are not going to use this anymore. So what we can do is, our first pass is done. From left to right pass is done. Now we have to do right to left pass. Suffix sum. So initially we are going to set it to the 1, and what we will do is, we'll initialize pointer here at this place. Okay, so far what is the suffix sum? It's going to be 1. Just multiply 6 into 1. What value you got? You end up in 6. Listen. And just update the current suffix sum. What is current suffix sum? Is going to be 4. Now move the pointer to this position. What is so far suffix sum? It's going to be 4. So just multiply 2 into 4. You're just going to get 8. You're just going to have 6. Okay. Now this value becomes 8. So what is the so far prefix sum? If you remember, we have to update at every single step. If you multiply 3, it's going to become 12. This is our so far suffix sum. And if you move to the 12, and if you move to the 12, you will multiply 1 into 12, which will give you value of 12. And just update the so far suffix sum. Multiply by 2, we're going to get 24. Now just move to the first position and directly multiply 1 into 24, you will get 24. If you just draw out, if I draw out correctly, you will end up in 24, 12, 8, 6, the correct resultant array. And now if you see, space complexity is going to be of 1, because we are not using any kind of extra data structure to store it. Just simple variable to compute prefix and suffix. It's very simple and optimal solution. Now we'll have resultant array. Okay, resultant array of size n. It's going to be n size. Now we'll just iterate from left to right. For I is going to be 0 up to the n. Now we have prefix. Prefix is going to be 1. As I said, we'll initialize to the 1, and we will update the result before updating the prefix. If you remember, we just update this value and then only we just update the current sum, isn't it? What you can do is, we can directly append the prefix, and here prefix will be nums of I. That's it. This right to left pass is done. Sorry, left to right pass is done. Now let's work on right to left path. Okay, suffix. Suffix is going to be 0. So sorry, suffix is going to be 1. I'm going to start loop from n minus 1 till the 0th position. We'll start the loop from n minus 1 till the 0th position. Again, same thing here. What we'll do is, we'll update the resultant array, will not create array. If you see this position, if you remember, we just add the value to the resultant array when we go from right to left. But while going from left to right, we just update the array. We just take the previous value and multiply with the current suffix, if you remember carefully. Okay, now let's write the code for that. For this, what you have to do is, you have to take result of I multiply with suffix. Very simple solution, right? Now what you have to do is, update the suffix. Current suffix is going to be nums of I. That's it. Very simple. Return result. This is very optimal solution, with time complexity of O of n and space of O of 1, or we can tell it's constants. It's very simple solution, right? Now let's move to the coding part. This is a problem number 238 from the lead code. It's a medium problem. The reason, because as we discussed, it doesn't support more than 32-bit integer, and you have to do an efficient algorithm. That's why it's in the medium category. If there is no constraint on this, it's going to be an easy one, because you can easily divide with the total product of it. And here there's a catch, which is not possible. That's a reason they make it as medium one. So let's code this up. So prefix is going to be 1, and if you see, suffix is also going to be 1 by default. Now let's declare the resultant array with the default value of 1. Okay, 1 into the length of nums. Now we'll just go from right to left path. For I in range from 0 up until the length of nums. Now if you remember, for result we'll directly append with prefix value. Now we'll update the prefix value. Prefix star is going to be nums of I. Now what we'll do is we'll do from right to left scan for I in range from length of nums minus 1 till the last value. If you remember carefully, we'll update this one. Nums of I multiply is equal to suffix. Let me see the name what I give. Okay, I'll just remove 1f. Now if you remember, we'll update suffix also. Suffix multiply is equal to I. This is going to keep track of so far suffix. Now we can directly return the result. Yes, it passed all the test cases. Now let's submit this. Yeah, our code passed everything. Thanks for watching till this year, and we'll see you in one more video tomorrow. Until then, bye.